Alright, here we go. We're graphing radical functions. And the first one here is the parent function. And the parent function is the one that we will move up, down, left, and right, stretch, and compress. And I'm going to try to show you how that happens based on the equations we use. First off, let's build a t-chart. And before that, let's go through perfect squares. The perfect squares are 1 comes from 1 times 1, 4 comes from 2 times 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 36, 49, etc. I want to know that because when I plug in for x, I need something I can actually take the square root of. So building my t-chart, I have my x of 1. Sorry, I want to use an x, yes, of 1. My square root of 1 is 1. Using an x of 4, I have a square root of 2. If I take 9, I have a square root of 3. If I use 0, a little out of order here, square root of 0 is 0. If I use a negative 4, if we use a negative under a square root, we learned that was an imaginary number. So that is actually undefined. We are not graphing imaginary numbers. So if I graph 0, 0, 1, 1, each block is 1 unit, 1, 2, 3, 4, 2, 4 2's right there, and then 4, 5, 6, 7, 8, 9, 3, 9, 3 is somewhere out here. I then can draw my curve, and it looks like that. And that is my parent function. That is y equals the square root of x. Now, looking at the next function, let me change colors. Hope this is blue. It's more purple. Let's try the other one that is more blue. Okay. So y equals the square root of x minus 2. And I was going to try to change to a different color, but we'll stick with this. Sorry, not used to using colors. X minus 2. What that does, it moves every x 2 units to the left. I'm sorry, to the right. That sign we're going to take as the opposite sign, so we're going to take a plus 2. So it means every x is going to get moved to the right 2 units. So that means this point right here gets moved 1, 2 units. This point gets moved 1, 2 units. The point 4, 2 gets moved 1, 2 units. So our new curve looks like that. So blue and blue curve go together. But what happens if we have a red? Y is equal to x plus 3 under the radical. We're going to take the opposite sign. That's minus 3. And since it's with the x, this is all together with the x, it's a left-right movement, and it moves to the left 3 units. So taking my parent function, so that 0, 0 point, I'll move it back 1, 2, 3 units. The point 1, 1, I'll move back 1, 2, 3 units. The point 4, 2 in my parent function, I'll move back 1, 2, 3 units. And now I can build that function. So that's what happens with everything under a radical. If we move to the next topic, let's go back to green. I'm going to graph my parent function 0, 0, 1, 1, 2, 3, 4, 2. I'm not going to graph that 9, 3 since I don't have a graph that goes out that far. So this is my parent function, y equals square root x. Now looking at blue, I have y is equal to the square root of x minus 3. This, we take the sign as it is, so this is minus, which means down 3 units. So that means every point gets moved down 3 units. From 0, 0, it moves down 1, 2, 3 units. My point 1, 1 on my parent function is moved down 1, 2, 3 units. The point 4, 2 on my parent function gets moved down 1, 2, 3 units. And now I can draw my new curve. If I have y is equal to, changing to red, y equals x plus 4. That plus 4 means up 4 units. So that means my parent function, the green function, I move 0, 0 up 1, 2, 3, 4 units. I move my point 1, 1 from my parent function up 1, 2, 3, 4 units. The point 4, 2 from my parent function, I move up 1, 2, 3, 4 units. And I draw my new function. What happens when we combine these? So I'm going to go a little off my script here. Let's cross that out, and let's do y equals square root x minus 2 plus 3. I'm going to go back and draw my parent function in green. Go back 0, 0, 1, 1, 4, 2, 3, 4, that is 4, 2, and draw my curve. That is y equals square root x. And now going back to the blue function, y is equal to x minus 2, that we're going to take as a positive 2, it means it moves to the right 2, and it moves up, because of the plus sign, 3 units. So it moves right 2, up 3. So every point, I'm going to move 0, 0 from my parent function, right 1, 2, and then 1, 2, 3. I'm going to move the point 1, 1, right 1, 2, and then up 1, 2, 3. I take the point 4, 2 from my parent function, move it right 1, 2, move it up 1, 2, 3, and draw my new curve. So that's how we combine everything together to draw our curve. We can always fall back on our, sorry, that should be a y, on our t-chart. It's just harder sometimes to get numbers in for your x that you can actually take a square root of to be able to graph. Take a square root of 2, you get a decimal 1 point something, and that's hard to graph. So if you can learn to move based on the translations, this will be a little bit easier, a little bit faster for you. I hope this helps.